Let's travel back in time for a moment. It's the year 1918, and we are in the USA. Every morning, Jane and Alice from that photo deliver ice to homes and restaurants. People use that ice to preserve food. They store that ice into something that looks like a fridge. However, that fridge is not powered by electricity. Interestingly enough, electric fridge was invented 5 years ago, in 1913. However, it's not widely adopted yet. After some years, more and more people will start buying electric fridges, and after some time, Jane and Alice didn't have any ice to deliver anymore. Nobody used ice. Let's travel back to the current moment. It's the year 2024, and we are all in Sofia for JPrime conference. GitHub Copilot, ChatGPT, and other generative AI tools have been invented 2 to 3 years ago. How are they going to change software development? Are these going to replace software developers? Of course not. Generative AI tools are not here to replace developers. And that's exactly the topic of our session today. By the end of our session, you will learn 3 things. First of all, how to harness the strengths of generative AI tools, how to be aware of the weaknesses of these tools and make the best to avoid these weaknesses. And the third is we will try to figure out what will happen in the future and how the job of software developers will change. My name is Ioannis. I work at Accenture. I am based out of Athens, Greece. I started programming in BASIC with an Amstrad computer that had a green screen. And my first job was as a Java developer, developing Java applets in Java 1.2. I still develop applications today using GitHub Copilot and other similar tools. And what I'm going to share today with you is part of my experience and my experimentation with these tools. Before we start, I have a question to ask. Do you use AI coding assistants like GitHub Copilot? Please raise your hand if you do. Great. I see quite a few hands here. First of all, we're going to explore the weaknesses of AI-assisted coding. There are 3 weaknesses. First of all, when we generate new code, this code tends to be functionally incorrect. What this means is if we run unit tests, then some of these tests, or even all of the tests, will fail. The second weakness is when we use these tools to refactor existing code. Again, they will likely break existing code, and the unit tests we have will fail. And then the third weakness of these tools is that they have a negative impact on software quality, making it harder to read and maintain the code. Stay tuned for more details. Let's take a look at a code prompt. What you see is Java code, and it's a prompt that contains a detailed Java doc documentation. We explain what this method does. We explain the method parameters. So we have 2 parameters. The first one is a list of numbers, and the second parameter is a threshold. What this method should check is whether the numbers in that list have a distance between them that is smaller than the threshold. If the distance between the numbers in the list is smaller than the threshold, then that method should return true. Otherwise, it should return false. As you can see in the Java documentation, we even have 2 examples of how this method works. You can think of these as unit tests, but they are just comments. And we also have a descriptive name for that Java method, which is called hasClauseElements. We try to make both the comments in the Java doc and the method name as descriptive as possible to help GitHub Copilot generate the right code. Let's see how this works in practice. So this is the same code example in Visual Studio Code, and when we press enter, GitHub Copilot recommends the code in gray color. We inspect that code, and when we press tab, we accept it. So now it's part of our code. It's the method implementation for that method. And it is as simple as that. Will that code work? Who knows? We have to test for that. So the first weakness of these tools is that they generate new code that is functionally incorrect. Most likely, when we run unit tests, these unit tests will not pass. According to research from a university in Turkey, from Bilkent University, they evaluated 164 different problems. They provided 164 different code prompts, like the one we just seen. And they used 3 different tools: ChatGPT, GitHub Copilot, and Amazon Code Whisperer to generate the code. And after they did that, they ran unit tests to verify if the code proposed by these tools was correct, functionally correct or not. As you can see from the table here, ChatGPT generated code that was functionally correct only for 65% of the problems. In the rest of the cases, some unit tests or all of the unit tests would fail to pass. GitHub Copilot generated the correct code only for 46% of the problems, and Amazon Code Whisperer generated the correct code only for 31% of these problems, which can be quite alarming, considering that most of us have started using these tools to generate code. What they found in that same research is that the functionally incorrect code was most likely to happen whenever we had longer and complex prompts, whereas simpler prompts, providing simpler instructions, would likely generate functionally correct code. What they also tried is providing generic method names like foo method names that didn't provide the intent of what these methods were supposed to do. And again, providing generic names tends to generate incorrect code. So one more important point is providing descriptive method names that explain what we want to do with our code. Therefore, the trick of being a 10x developer is being able to take big, complex problems, break them into smaller problems that are simpler for the coding copilot to understand, and then write the prompts, write the method names and the comments for these simpler problems. So as you can see, GitHub Copilots and other tools cannot do all the magic unless you have a 10x developer that would use their human ingenuity to break complex problems into smaller ones. And that's what you need to remember here. Summarizing all these and putting them together, we need to write code prompts that have clear and accurate problem description. We need to provide sample unit tests in the Java doc, just like we did in the first example. And we need to provide descriptive method names that show our intent. Let's move on to the second weakness, which is about refactoring existing code. Here we have a different research from CodeSyn and Adam Thornhill, where they refactored more than 100,000 code smells in JavaScript and TypeScript. And then they also run unit tests to check whether the refactored code was correct. As you can see, it is more likely that these AI coding assistants will fail when refactoring code. Google's Palm 2 model performed correct refactoring only for 37% of these 100,000 refactorings. GPT 3.5 performed correct refactoring only in 30% of the cases, and then a fine-tuned model of Code Llama performed correct refactorings only for 18%. Yes, that's correct, 18%. The rest, approximately 82% of the code was incorrect. By looking closer into the code that was incorrect, they found out that when refactoring nested ifs, if, else if, then these tools would usually drop some of the if or else if blocks. That's the most common mistake that they discovered. And it would also inverse Boolean logic by putting this exclamation mark, as you can see in the example. For these reasons, 10x developers always verify that their refactor code is correct by running unit tests and carefully reviewing the code. These established practices are more relevant than ever. We still need them. And as a matter of fact, only software developers who are used to these practices, to writing unit tests and reviewing code, only these developers can effectively leverage AI coding assistants. It's time for a quiz. Where do you think that we spend most of our times as software developers? Is it writing new code? Raise your hand if you believe that we spend most of our time writing code. No one? Okay, let's go to B. Do we spend more time reading code, existing code? Yeah, I see many hands. Do we spend most of our time waiting for a full build to complete? I also see some hands, great. Or do we spend most of our time in other activities like meetings and drinking coffee? Okay. According to research, we spend 70% of our time reading code and only 5% writing code. It's quite surprising because all the hype around AI coding assistants is that they help us write code faster. Who cares? We spend most of our time reading code, especially for legacy applications. We try to understand what the code does. That's the struggle. So is there some way that we could use AI coding assistants to read our code faster? And that's the third weakness related to AI coding assistants. They make it harder to read code. They make it harder to maintain code. According to a research from GitClear, they analyzed 153 million lines of code that have been changed from January 2020 to December 2023. Since the introduction of GitHub Copilot and ChatGPT, there has been an increase in code being copied and pasted. This results in duplicate code. First of all, what's the disadvantage of having duplicate code in our code base? First of all, it takes more time to read the code and understand what it does when you have the same code copied in 2, 3, 4, or even more locations in your code base. And whenever there is a bug, you need to go through all these code fragments, which are essentially the same, and fix all of these. And if you forget one of these code fragments, then you have a bug. So it's quite error-prone having duplicate code in our repository. And whenever we want to fix a bug or extend its functionality, it takes more effort from us reading it, then changing it, and then testing it for all the different code paths that go through these different code fragments. Let's think for a moment why this happens. Why is there an increase in copied and pasted code? Because that's how these tools work. They only recommend adding new code. They just write code. They never propose reusing an existing Java method in our code repository. Or they never propose deleting some code or merging two duplicates, which is typically what experienced developers, 10x developers, do. The same research also found out that there is a significant drop in reused and refactored code. It's essentially the same observation that AI coding assistants do not promote code reusability, which is something critical when maintaining applications. According to the same research, they realized that the code produced by AI coding assistants resembles the work of short-term contractors. What do we mean by short-term contractors? I have nothing with them. You know, a short-term contractor can be an excellent programmer, for example, in Java, and have excellent skills. But when they join a new project, they are not familiar with the code base, especially if we think of a legacy application that's been around for 10 years or more. Therefore, it's easier for these short-term contractors to write new code instead of reusing existing code, because they are not aware of the existing code. They may have millions lines of code in the existing code repository. However, the strength of existing code is that it has been tested in production for many years and it's stable code, versus the new code being generated by these tools, which has not been tested. Therefore, what we see is that there was this bad practice where we would search for solutions to our code in Stack Overflow. We would copy and paste that code in our repository, and this was somehow a conscious process. We did that consciously, even though we knew that this is not the best approach. What we've done now is that we have automated this process with tools like AI coding assistants. We don't have to copy and paste anymore. We have automated that process, and the copy and pasting happens implicitly in the background. For these reasons, 10x developers prefer reusing existing code than copying and pasting the code via AI coding assistants. That's why they can read their code and maintain their code 10 times faster than the rest of developers. Moving on, we will explore 3 strengths of AI-assisted coding. First, helping us explore new technologies and develop prototypes faster. Second, understanding code and enhancing its performance. And third, generating unit tests that act as a safety net before we proceed with any changes to our code. Yesterday, I arrived in Sofia, and I wanted to explore the city center and view the main sites, visit some monuments. And I used Google Maps to walk around the city center. That's what we all do when we want to explore a new area that we are not familiar with when visiting a new city. That's exactly how I feel about AI coding assistants like GitHub Copilot. I find them very useful when exploring new technologies, when exploring new frameworks or new third-party libraries that I haven't used before. That's actually a part of my job role. I frequently have to explore with new technologies and build prototypes, proof of concepts. We also call these throwaway prototypes. And previously, I would have to spend 4 or 5 days to build a throwaway prototype. But nowadays, I can build that within a day or even faster, because GitHub Copilot helps me explore these new areas. For example, I needed to run some performance tests the other days using Java micro benchmark harness, and I didn't have to read any documentation. I just asked GitHub Copilot, it provided me some sample code. Then I would also ask about the different Java annotations in the code, what they mean, what are the alternatives, and I would constantly get feedback. I would get the advice on what I needed to do to achieve my goals while building that prototype. And I also found out that it helps me stay focused. Previously, I had to search on Google for whatever I wanted to build. I would usually find some code on Stack Overflow. There would be some links, read that blog. I would also read these blogs. Then in some of the blogs, they would recommend watching a conference video. I would also watch that conference video. And after 1 hour, I would be wondering, what am I doing here? Why am I watching that video? And only then would I realize that I was trying to build something in the first place. So summarizing, I found out that a tool like GitHub Copilot helps me stay focused when writing code, because I only do that inside my IDE. Therefore, 10x developers use AI coding assistants to move fast and break things. And what we mean by breaking things, when exploring new things, it's part of the process. You have to break things until you learn how to get it right. And these tools help you break things and fix them faster than I would have done manually. And unless we break things, we don't learn. That's also part of the learning process. Here's the second strength. Tools like GitHub Copilot help us understand code. And once we understand how the code works, then we are better positioned to improve its performance. Can you recognize what this algorithm does? Sorry? That's great. That's correct. However, I wasn't able to find it on my own. It felt just like when maintaining legacy code. I would look at code like this one, no comments included, no hints of any kind, and I was wondering what it does, scratching my head. Not anymore. Let's take a look at a demo and see how GitHub Copilot can help us figure out what that code does. On the right, you can see GitHub Copilot chat, and I'm typing a question. What is the algorithm used in the selected code? Yeah. As a matter of fact, you found it faster than GitHub Copilot. It takes more time. As you can see, it tells us that the selected code is bubble sort and explains what happens. It is a simple sorting algorithm that repeatedly steps through the list, compares adjacent elements, and swaps them if they are in the wrong order. Let's have a follow-up question. Recommend alternative algorithms that can sort the numbers more efficiently, taking less time to execute, consuming less CPU and RAM. We get a hint about the time complexity of bubble sort, and we get 5 different alternatives: quick sort, merge sort, heap sort, team sort, and radix sort. And for each one of the algorithms, we get their time complexities and some hints where they would perform better compared to bubble sort. Therefore, figuring out what algorithm we are using in this code fragment was the first step, and then the second step is looking for alternatives. And in all these steps, GitHub Copilot can help us achieve a better understanding and improve the performance of the existing code. So in our case, we ran some experiments and measured the execution time needed to sort an array of 1,000 numbers with bubble sort and quick sort. And as you can see, we achieved a drastic improvement in the performance, reducing the execution time by 95%. That's just an example of what you can do with such a tool. And we didn't have to write the code in quicksort. GitHub Copilot generated that code for us. It was just a matter of selecting the code and asking from the tool to rewrite it for us. Therefore, 10x developers use AI coding assistants to understand code and identify opportunities to improve its performance. That's why their code runs 10 times or even 100 times faster. The third strength of AI coding assistants is that they help us generate unit tests, which act as a safety net before we make any changes to our code, either for fixing bugs or enhancing their functionality. Let's take a look at the same example. It's the same method, has-close elements, where we previously generated the code with the help of GitHub Copilot. We just asked from GitHub Copilot chat to generate the tests for us. It tells us it will use JUnit to write these tests. This is Java code. And it identifies 4 different test scenarios. One where the elements in the list are close, and therefore the method will return true. The second, where we provide the method a list that doesn't have close elements, and therefore we will return false. The third one, we provide an empty list, and in the fourth one, we provide only a single element in the list. We have the code ready there. We don't have to do anything. The only thing we need to do is to copy the code and paste it into a method class. This time it's allowed to do a copy and pasting, no problem. Okay, this is the method name. And now we will paste the code. Okay, we have all 4 unit tests. And next we run them. And all tests passed. Now we can safely proceed if we want to the next step, refactoring our method, because we have these unit tests that act as a safety test, which is very critical, especially for legacy applications where we may not have any tests at all. So this functionality can be really helpful. Therefore, 10x developers move fast and don't break things, because they use AI coding assistants to generate unit tests, which act as a safety net. It's time to look into the future and think how is software development going to change due to generative AI and all the advancements in artificial intelligence. This is an example of how we can use ChatGPT, providing a photo to ChatGPT and asking from ChatGPT to explain what it sees in the photo. So the question is, what do you see in the photo? and it tells us that the photo shows a dog with curly fur wearing a pair of headphones. The dog appears to be enjoying the music with its eyes closed and an expression of contentment. The sky in the background is clear and blue, giving the image a cheerful and serene atmosphere. The dog is also wearing a blue bandana around its neck. It can be really surprising. If you asked me, I would tell you I see a dog, and that's all. I wouldn't be able to provide that level of details. So let's look a bit under the hood. First of all, you see on the left, on the first step, the photo that we provide to ChatGPT. In the middle, you see what ChatGPT, it's a representation of a neural network. It is essentially a large language model. And then on the right, you can see the response of that large language model. And I want us to carefully think about it. Can anyone here write Java code that implements the same functionality that this LLM provides? Could we somehow write a Java application, and when we provide a photo to that Java application, it would explain to us what is shown in the picture? Is this possible? And this has to work for any photo, not just for that dog photo. Any photo we provide, that Java application would have to explain what is shown in the photo. So it's impossible. We can't do that with a high-level programming language. So what is interesting here is that there is a new field of problems that we can solve that previously we couldn't solve with conventional tools like a Java programming language. And what's interesting is that if we look again under the hood to see what is beneath this LLM, we program these LLMs by providing vast volumes of data, vast volumes of text, images, audio, video. And what we get on the other side, after training these models, is billion of parameters, billion of weights and balances in these neural networks. For example, GPT-3 has 175 billion parameters, and each parameter takes 2 bytes. That's a total of 350 gigabytes. Can a human look at all these parameters and somehow debug them? It's impossible. There is not a single human on Earth who can fully understand how these large language models work. It's pure mystery. We just know that they work, but we cannot debug them or explain how they really work. In contrast, if we look at Java applications, we write Java code. When we compile it, we get bytecode. And when the Java virtual machine runs that code, it converts it to machine code and executes it on the underlying hardware. Most of us here understand Java code. Fewer understand bytecode. And even fewer of us understand machine code. Still, we can find some humans who can fully reason about the code, how it works, and debug it if something fails. That's the critical difference between these programming models, if we can call them that way. Here is an interesting coding challenge. How would you build a software application in Java that would find the cheapest flight tickets from Sofia to travel to the upcoming Oracle JavaOne conference? How would you do it? First of all, if you notice, we don't specify when the conference is taking place, what are the dates, and we also don't specify where it is taking place, which country, city. Therefore, we would have to somehow build an application that searches dynamically on the internet for that information. It somehow parses the results from different HTML pages, extracts that information, and then queries a website using some API and fetches the cheapest flight tickets. That's a lot of work. How could we hack this and do this faster? It turns out that we can use an LLM, a large language model, like ChatGPT. Let's take a look at a demo of a custom ChatGPT implemented by Kayak. So that's the query you've seen. Find the cheapest flight tickets from Sofia to travel to the upcoming Oracle JavaOne conference. It searched on the internet and found 3 websites. And from these websites, it tells us that the conference is taking place from March 17 to March 20 at Oracle's campus in Redwood Shores, California. And then it asks us if we want to search for flight tickets on Kayak. We click on Allow. It talks to kayak.com. It takes some time. And then we get the cheapest flight tickets. Isn't that impressive? And we can also inspect the JSON arguments that were passed to Kayak while doing the search for flight tickets. That's what the LLM has done on its own. And we can also check out the links that it found on the internet. And it extracted the information about the dates of the conference and the location of that conference from these web pages. And the most interesting thing is that we didn't implement any code. Let's take a look at this diagram to understand how this changes the way we've been developing software. On the left, you can see a user, that can be a developer or any other kind of user, that asks a question to an LLM. The LLM acts as an orchestrator. It figures out what information is missing and how to retrieve that information. It is able to query different systems. First of all, it can search on the internet for that information, or it could query a database, or it could query an ERP system using some APIs. It collects that information from all these systems, merges that information, and then provides the answer to the user. And all this happens without writing any code. It's all a matter of training the large language model using some simple prompts. Summarizing what we learned today, we've seen 3 weaknesses of AI coding assistants. First of all, they generate code that is functionally incorrect, meaning that it fails some or all of the unit tests. The second weakness is that refactoring existing code will likely break our code. Third weakness is that they can negatively impact code quality by implicitly copying and pasted code and never reusing existing code. And then we've also seen 3 strengths. First of all, helping us explore new technologies and develop throwaway prototypes much faster than before. Second strength is that they help us understand code, understand bubble sort, and enhance the code's performance once we figure out how it works. And the third strength is around generating unit tests. This is quite essential, especially when we figure out how error-prone these AI coding assistants are. And we also talked briefly about the 3 different software development paradigms. The one on the left you are all familiar with. We generate code, Java code. It can be humans, AI coding assistants, both working together to build Java code. That's straightforward. In the second model, we have large language models, and we train these models. We program these models using vast volumes of data. And in the third model, which is one of the most interesting ones, is blending these two models, mixing them and integrating them and creating innovative solutions out of them. And now the million-dollar question. Will AI replace developers? Of course not. I'd like to draw some inspiration from airplanes, where the first autopilot was invented in 1912, more than 100 years ago. Still, we have humans. We have at least 2 pilots piloting these airplanes. And the main reason we have them there is as the human in the loop to monitor all the systems, monitor the plane's trajectory, figure out if something goes wrong, and then apply corrective actions to fix any issues that come up. In the same sense, I believe that developers will always be the human in the loop, especially for mission-critical software applications. There are so many mission-critical software applications. Think about all the applications processing trillions of euros for banks. Think of the systems that help us produce electric energy, that help emergency services respond to emergency calls. There are so many mission-critical applications. What will change, however, is the role of the developers. Just like in the 1950s and 1960s, developers would program in assembly language and had to know everything about the hardware processors. When high-level languages were introduced, then the job role of the developer also changed. We don't need to know all the hardware details or code in assembly. In a similar fashion, with the introduction of tools like GitHub Copilot, we don't need to get into too many details about the Java code, but we program in a higher level abstraction, mostly providing natural language prompts, that is English language. And the developer will gradually shift to a role of having the overall picture and supervising things and making sure nothing breaks. So it will be mostly something like an architect or a product manager or a blend of these roles. What can we all do to become 10x developers? 3 simple things. First of all, writing unit tests and carefully reviewing the code is more relevant than ever. This is not an outdated practice. As a matter of fact, only developers that apply these practices can safely adopt AI coding assistants. Second, use AI assistants to read your code and understand your code, especially for legacy applications where this is harder to read your code. And third, start exploring these new software development paradigms that we just explained. Most important, this blend of large language models and code. Do you have any questions about how to become a 10x developer? Okay. Okay. I didn't hear. Okay, so someone said we are already 10x developers. You can become 100x now with the help of GitHub Copilot.